colleague Harun worked on it. He's the Ferrari logo on the Discord. So yeah, he is the one. Yes. So he couldn't make it here. So, but if I say anything wrong, he can correct me if he wants to. So overall, TetriSaraj. So it's a wordplay on Tetris, the very popular game, and Saraj, which is Sarajevo, the place that this adaptation of Tetris was made. So it's an open source FPGA Tetris with a twist and an innovative design using open source tools. So, so the motivation for creating it was to provide an accessible, engaging way to showcase FPGA design, for it to be open source, and to engage younger students by demonstrating a fun, recognizable application with a twist, as I said. So here it's a tribute to Sarajevo, merging Tetris with the city's creative spirit. It's the first truly independent real-world use of OpenXT7, which is a remarkable thing because OpenXT7 uses the Arctic 7 chips, which are pretty popular. The Basis board uses them. Both of our Alinks board use OpenXT7, so we are going to use it even more. So multiple issues fixed. So Harun and another colleague Karim worked on this. So it was, like with any open source tools, it takes some time. Bugs and hacks were reported. That they were truly alpha testers. So the classic Tetris is just that we have all played it. So it's the differently shaped tetrominoes, so to say, descend onto the playing field. So the main objective is to fill the horizontal spaces, and when you fully fill a space, it clears up automatically. So the game ends when the stacked pieces reach the top. And in multiplayer mode, the goal is to outlast the other opponent. So my colleagues created a truly fresh take that reduces time to think strategically, adds complexity. Pieces enter randomly from both sides. Aside from entry direction, core Tetris mechanics remain the same. So this is what they made. So they made a multiplayer game, Tetris, that the blocks fall randomly from the sides and you can play against another person simultaneously, so at the same place. So the two main solutions is the solution tracks developed, so the hardware and software side were developed in parallel. The hardware team built the Basis 3 SoC, and the software team worked on the game algorithm. Okay, so they didn't use a logic simulation, they used the terminal emulation of the game logic. So it was a gruesome process. They told me that to build to synthesize the entire design took them around 30 minutes when they made one change in the code. So later on they found a way to upload the changes through UART, so they didn't have to rebuild the process the entire time when they made a change in the C code. So here the video controller was validated not through simulation but directly using simpler C-based patterns. And here we see that they, as I said, a simple platform agnostic CPU program upload over UART. And here I'm going to, these are the specifics about the display, about the colors per pixel, the, I think it's called mega character, so the MC is for mega character frame buffer. And the Tango Nano 9K can also use the board, the TetriSaraj, so it's pretty low cost. So now here this is one character, so this is the 1 pixel, and this is the pixel, and each pixel is 16 by 16. So overall the screen is 40 by 30, which is equivalent to 640 by 480. it's RGB 444, so it takes 12 bits to store one data, and so this is how everything is organized. So the memory size of one pixel is 384 bytes. So they had to memory map everything. I don't know if there's a slide, but there is. Okay, so everything was mapped into memory. There was one memory that was for the mega characters, and the other memory was for the entire 40 by 30 plane, so to say. So each on-screen element contains a 4-bit code pointing to one of these 16 characters. A separate character memory map allows per pixel coloring using the lower 12 bits, and the memory map ensures a clean contract-based design for consistent hardware software integration. And installation can be done with a single command. It's pretty easy to do. The repository is pretty well documented, and the porting, as I said before, this is pretty interesting. So on Arctic 7 the design hits 100 megahertz under the open source tool, but Gateway's FMAX stopped at 16 megahertz for the original version, and they had to modify a lot of things to make it work under 31 megahertz. And they did that because the VGA controller requires 25 megahertz. So the entire system was scaled down to 25 megahertz, and the entire design originally was at 100 megahertz. So they created the 100 megahertz design originally to have some space, because the VGA required 25 megahertz, so they had 4 cycles of space to work with. So it was a pretty big task for them to port it because of this. Overall, the RTL and code that was written was pretty easily implemented on the other one, just this clock constraint was pretty challenging. So here are the closing thoughts.
Because you have large pixels, I think you can go VGA with much lower frequency. The timing will be still, it will think it is a 25 or 30 watt megahertz, but if your pixels are larger, you can just run it on the very lower actual code.
You think that they could have used lower than 25 megahertz?
Lower, yeah. Lower. Only the clock must go 31 or whatever, but actual core could be much lower.
Okay. I think that they probably tried that. So I mean, Harun can join if he is listening. But I think that was their. They had a reason probably why they didn't do that. Because
the pixel, Joseph, the pixel is not huge, but we have a mega character there. It's almost like a sprite. It's not exactly a sprite. It's more than a sprite.
Okay.
It's a 16 by.
Okay, so.
Right, so it's.
Okay.
It's greater than a normal character. It's smaller than a sprite. It's 16 by 60.
Okay, then.
And that's what frame buffer operates. Frame buffer is 40 to 30, right? Of mega characters.
yes.
Okay, it explains, yeah.
Yes. Thank you, Yasmin. Here we have overall the demo as well. I think that Goran can. So it's an interesting take, and
it has 2 players.
Yes, it has 2 players, and this one is the first extension board that Goran made, so it's revision 1. Now he made the board better with joystick that can be easier to control this, and more intuitive than using the 4 buttons below.